Big Freeze, the eternal cold of the cosmos. Big Freeze, the eternal cold of the cosmos. Welcome to an epic journey through the possible destinies of the universe, a mystery that has challenged the human mind for generations. What awaits the stars, galaxies, planets, and even light itself when time reaches its final chapter? In this video, we explore three fascinating theories about the end of the cosmos. And we begin with the Big Freeze, a scenario in which the universe expands forever, diving into a cold, dark, and silent void where motion ceases and silence reigns. Prepare yourself for a story that stretches to the edge of time. But know this. This is only the first part of our exploration. Other equally stunning destinies await. The Big Freeze is based on a cosmic truth. The universe has been expanding since the Big Bang. For about 13.8 billion years, space has been stretching, like the surface of an inflating balloon. Galaxies, those islands of stars, gas, and dust, are moving away from one another at speeds that defy imagination. In the Big Freeze scenario, this expansion never ends. Driven by a mysterious force called dark energy, it ensures that the universe keeps growing endlessly without reversal. Dark energy is one of the greatest mysteries in cosmology. It makes up around 70% of all the energy in the universe, but its true nature remains unknown. Unlike gravity, which pulls planets and stars together, dark energy acts as a repelling force, accelerating the separation between galaxies. Imagine a cosmic stage where the actors, the galaxies, drift farther and farther apart, leaving the scene completely empty. In the Big Freeze, the universe is that stage, and expansion is the script that leads to a frozen ending. For billions of years, the universe will still appear vibrant. Stars will be born in clouds of gas, shining with brilliance. Galaxies will collide, like the Milky Way and Andromeda, which will merge in about 4.5 billion years, forming a giant elliptical galaxy. Supernovas will explode, spreading heavy elements that might form new star systems. But over time, the fuel for this cosmic show will begin to run out. Hydrogen and helium, the building blocks of stars, are limited. And the universe's expansion will thin out the interstellar gas clouds. In about 100 billion years, star formation will all but cease. Massive stars, which burn through their fuel quickly, will explode in supernovas, leaving behind black holes or neutron stars. Smaller stars like our Sun will take a slower path, becoming white dwarfs, dense stellar remnants that shine faintly for billions of years. Eventually, even these white dwarfs will cool down, becoming black dwarfs, cold, invisible objects devoid of light or heat. As the universe expands further, galaxies will grow increasingly isolated. Dark energy will push them so far apart that eventually no galaxy will be visible from another. The night sky, which now dazzles us with stars and nebulae, will become a black void, lit only by the cosmic microwave background, a faint whisper from the Big Bang. Even black holes, which seem eternal, won't survive forever. Through Hawking radiation, a quantum process discovered by Stephen Hawking, they will slowly evaporate, releasing particles over unimaginable time spans. Roughly 10 duodecillion years for stellar black holes, and over a Google years for the supermassive ones at the center of galaxies. When the last black hole vanishes, the universe will be nearing its final destination: thermal death. Temperatures will approach absolute zero, minus 273 degrees Celsius, a point where particle movement is nearly non-existent. Entropy, the measure of disorder, will reach its maximum. There will be no usable energy left to perform any kind of physical work. No heat, no light, no motion. The universe will be a sea of scattered particles, drifting through infinite space, not interacting, not colliding, forming nothing new. it will be the final silence. The end of all possibilities. The big freeze confronts us with the impermanence of everything we know, the galaxies dancing across the sky, the stars lighting up our nights, even the atoms that form our bodies. All of it will dissolve into a cold void. It's a scenario that brings both melancholy and wonder. Trillions of years will pass before this fate comes to pass. And in the meantime, the universe will continue to dazzle us with its beauty and complexity. We are fortunate to live in an era where the cosmos still shines, where life is possible, and where we can look up and contemplate the infinite. But the big freeze is only one possibility. What if the universe doesn't expand forever? What if instead it collapses in on itself in a cataclysmic event? In the next part, we explore the Big Crunch, a scenario where Big Crunch. The cosmic collapse gravity gathers the cosmos into a burning embrace. Stay with us. The story of the end of the universe is just beginning. Big Crunch, the cosmic collapse. We continue our journey through the possible destinies of the universe, exploring the scenarios that may mark the end of everything we know. In the first part, we dove into the Big Freeze, where the universe expands eternally, fading into a cold, silent void. Now we turn our eyes to an opposite, yet equally fascinating possibility: the Big Crunch, the Great Collapse. In this scenario, the cosmos does not dissolve into frozen emptiness, but is instead crushed into a single point of infinite density, an event as dramatic as the Big Bang itself. Prepare for a tale of colossal forces, where gravity takes the lead and pulls the universe toward a fiery end, as we leave the door open for what may come in the third and final part of this cosmic saga. The Big Crunch begins with the same premise that shaped the universe from its very beginning: the expansion triggered by the Big Bang nearly 14 billion years ago. Since that primordial moment, galaxies have drifted apart, like dots on the surface of a balloon being inflated. But unlike the Big Freeze, where dark energy ensures endless expansion, the Big Crunch relies on gravity's victory. This force, the one that keeps planets in orbit and holds galaxies together, could, under certain conditions, reverse the universe's expansion, pulling everything back into a catastrophic collapse. The fate of the universe in the Big Crunch depends on its density. Cosmic density is determined by the total amount of matter, stars, planets, gas, dust, and energy, including the mysterious dark energy. If that density is high enough, gravity could eventually overpower expansion, slow it down, and even reverse it. Imagine a ball thrown into the air. It rises, slows down under gravity's pull, and eventually falls back to the ground. In the Big Crunch, the universe is that ball, reaching its maximum size before beginning to contract, gathering all that exists into one final embrace. In the early stages of the Big Crunch, the universe would still seem familiar. For billions of years, galaxies would keep moving apart, stars would continue to be born and die. But gradually, gravity would begin to win, expansion would slow, galaxies that once drifted away would start to approach one another. In roughly 100 billion years, the night sky would no longer be a vast canvas of distant stars, but a dazzling chaos of merging galaxies. The Milky Way and Andromeda, for example, are already set to collide in about 4.5 billion years. But in the Big Crunch, these galactic mergers would become common, creating gravitational chaos on a cosmic scale. As the universe contracts, its density and temperature rise. Colliding galaxies would trigger explosions of star formation, a cosmic frenzy of newborn stars before stellar fuel finally runs out. Black holes, both stellar and supermassive, would begin to merge, forming even larger gravitational monsters. Space, once stretching outward, would now shrink, compressing all that exists. The sky would grow hotter, brighter, a striking contrast to the cold emptiness of the Big Freeze. In the final stages of the Big Crunch, the universe becomes a hostile place. Millions of years before the final collapse, temperatures would soar to extreme levels, disintegrating planets and stars. Gravity would crush entire systems, and even atoms would begin to break apart under mounting pressure. In the very last moment, in a fraction of a second, the entire universe, all matter, energy, space and time, would collapse into a single point of infinite temperature and density, a state strikingly similar to what existed at the moment of the Big Bang. This is the Big Crunch, the great crushing where the cosmos returns to a primordial state. But what comes after that? Here, science enters a realm of fascinating speculation. Some physicists suggest that the Big Crunch might be the prelude to a new Big Bang, giving birth to a renewed universe. This idea, known as the cyclical model, proposes that the universe goes through an endless series of expansions and collapses, like a cosmic breath. Each cycle would erase the previous universe, creating a new reality with new physical laws, new stars, and perhaps new forms of life. However, current evidence, which points to an accelerating expansion driven by dark energy, suggests that the Big Crunch is less likely than the Big Freeze. Still, it remains an intriguing possibility. The Big Crunch is a story of destruction and renewal. It invites us to imagine a dynamic universe where gravity governs destiny, gathering everything into an event of epic proportions. Big Rip, the universe torn apart and conclusion. A contrast to the melancholic silence of the Big Freeze, the Big Crunch offered a fiery end and perhaps the promise of a new beginning. For us humans, the Big Crunch is a reminder that the universe is a place of balance, where creation and destruction dance on a cosmic scale. We live in a time when the cosmos is still expanding, full of light and possibilities. But the Big Crunch invites us to contemplate the fragility and the power of what lies ahead. Yet there's still one final destiny to explore, a scenario even more extreme, one that stretches the imagination to its limits. In this last part, we'll dive into the Big Rip, where the universe doesn't just expand or collapse, but is quite literally torn apart by the overwhelming force of dark energy. Stay with us, because the story of the end of the universe is about to reach its most violent chapter. Big Rip, the universe torn apart. And now, we arrive at the final chapter of our exploration into the possible ends of the cosmos. After the frozen silence of the Big Freeze and the fiery collapse of the Big Crunch, it's time to face the most violent scenario of all, the Big Rip. In this ending, the universe doesn't merely expand or fall inward. It's shattered into pieces by an uncontrollable force. Let's dive into this cosmic chaos and reflect, in the end, on what these three visions of the universe's fate reveal about our place in the cosmos. Like the previous scenarios, the Big Rip is rooted in the expansion that began with the Big Bang around 13.8 billion years ago. Galaxies continue to move apart, driven by dark energy, the mysterious force that makes up nearly 70% of the universe's total energy. But in the Big Rip, dark energy becomes even more destructive. Known by scientists as phantom energy, it doesn't just maintain expansion. It grows stronger as the universe expands. This leads to exponential acceleration, a rate of expansion so violent that it overcomes every force that holds the universe together: gravity, electromagnetism, and even the nuclear forces that bind atoms. At first, the Big Rip might resemble the Big Freeze. In about 20 to 50 billion years, galaxies will be so far apart they'll vanish from each other's visible horizon. The night sky, which today shines with stars and nebulae, will become a black void, lit only by the stars of our own galaxy, the Milky Way. But as time goes on, dark energy becomes overwhelming, triggering a progressive destruction on increasingly smaller scales, Roughly 1 million years before the final moment, expansion becomes so intense that it tears apart the gravity holding galaxies together. The Milky Way will be unbound, its stars flung in different directions like leaves scattered by a cosmic wind. Thousands of years before the end, even stellar systems will be destroyed. The gravity that keeps Earth orbiting the Sun will fail, and our planet will drift alone through an increasingly chaotic and violent universe. Planets, moons, stars, all will be torn apart, floating helplessly in a space expanding at unimaginable speeds. In the final moments, the Big Rip reaches its peak of violence. Minutes before the end, the expansion becomes so powerful that it overcomes the forces keeping solid objects intact. Planets like Earth will be shredded, reduced to fragments. Seconds before the end, even atoms will be torn apart. The nuclear and electromagnetic forces that hold protons, neutrons, and electrons together will collapse under the unstoppable pressure of dark energy. And in the final instant, the very fabric of space and time will unravel, dissolving the universe into nothing. No matter, no energy, no space, no time. The Big Rip is the absolute end, a total erasure of reality as we know it. It is the most extreme of all three scenarios, because it leaves no room for continuation or renewal. Unlike the Big Crunch, which might lead to another Big Bang, or the Big Freeze, which leaves behind a cold, quiet universe. The Big Rip obliterates everything. No remnants, not even particles adrift in the void. It's an ending that challenges imagination, confronting us with the possibility that the universe, in all its grandeur, might simply vanish in a cosmic blink. However, current evidence suggests that the Big Rip is less likely than the Big Freeze. Dark energy, while mysterious, does not appear to have the extreme properties of phantom energy needed to trigger such a tear. Still, the Big Rip forces us to face the fragility of everything that exists. Galaxies, stars, planets, even the atoms that make up our bodies. All of it could be undone by forces beyond our comprehension. It's a vision that humbles us, but also inspires us to appreciate the complexity and beauty of the universe while it lasts. And so, we arrive at the end of our journey through the possible fates of the universe. The Big Freeze, a cold, silent void that stretches into eternity. The Big Crunch, a fiery collapse that may hold the seeds of a new beginning. And the Big Rip, a total, irreversible destruction of all things. Each theory offers a unique lens through which to view the end. But which one is true? Science doesn't yet have a definitive answer. Current observations, which show an accelerated expansion driven by dark energy, point to the Big Freeze as the most likely outcome. But the universe is vast, and our understanding of it is still evolving. New discoveries may change everything we believe about our final destiny. More than predicting the future, these theories invite us to reflect on our place in the cosmos. We are a small part of a grand story, written in stars, galaxies, and invisible forces. The end of the universe may lie trillions of years away, a time span so immense that it escapes even our wildest imagination. But that distance in time doesn't make the present any less meaningful. We live in a unique era, a moment when the universe is still full of light, full of energy, full of life. Every star that shines, every galaxy that spins, every planet that orbits, is part of a cosmic spectacle still unfolding before our eyes. These visions of the end, whether it's the silence of the Big Freeze, the collapse of the Big Crunch, or the tear of the Big Rip, remind us that everything is impermanent. But they also inspire awe, wonder, curiosity. As long as the universe shines, we have the chance to explore, to learn, to create. We are witnesses to a fleeting moment in cosmic history, and it's up to us to make it count, to seek knowledge, to tell stories, and to dream of the infinite. The end may be uncertain, but the journey is ours, and it's only just beginning. We've reached the end of our exploration into the three great endings of the cosmos: the frozen silence of the Big Freeze, the fiery collapse of the Big Crunch, and the cosmic tear of the Big Rip. Three different visions, one inevitable truth. Even the universe, and with all its grandeur and power, has a limit. But until that end comes, we exist. We think, we create, and we look to the stars searching for answers. If this journey through time and space inspired you, leave a like, subscribe to the channel, and ring the bell so you won't miss our next cosmic adventure. Share this video with others who love the universe, and tell us in the comments, which of these theories fascinated you the most, or do you believe in a completely different ending? Thank you for watching. I'm Commander Marco, and this was another transmission of Stellar Chronicles. Until next time, and never stop looking up at the stars.